Rutgers University and Georgia Tech engineers have devised three ways to combat cyber attacks on 3D printers: monitoring printer motion and sounds and using tiny gold nanoparticles. 3D printers will be attractive targets because 3D printed objects and parts are used in critical infrastructures around the world. And cyber attacks may cause failures in healthcare, transportation, robotics, aviation, and space. Among several unique techniques, the Rutgers and Georgia Tech researchers are using cancer imaging techniques to detect intrusions and hacking of 3D printer controllers. Imagine outsourcing the manufacturing of an object to a 3D printing facility, and you have no access to their printers and no way of verifying whether small defects invisible to the naked eye have been inserted into your object. The results could be devastating, and you have no way of tracing where the problem came from. 3D printing, also called additive manufacturing, plays an increasingly important role in industrial manufacturing. But health and safety related products such as medical processes and aerospace and auto parts are being printed with no standard way to verify them for accuracy. Even houses and buildings are being manufactured by 3D printers. Instead of spending up to $100,000 or more to buy a 3D printer, many companies and organizations send software design products to outside facilities for printing. But the firmware in printers may be hacked. For this study, the researchers bought several 3D printers and showed that it is possible to hack into a computer's firmware and print defective objects. The defects were undetectable on the outside, but the objects had holes or fractures inside them. Other researchers have shown in a YouTube video how hacking can lead to a defective propeller in a drone, causing it to crash. While anti-hacking software is essential, it is never 100% safe against cyber attacks. So the Rutgers and Georgia Tech researchers looked at the physical aspects of 3D printers. In 3D printing, the software controls the printer, which fulfills the virtual design of an object. The physical part includes an extruder or arm through which filament, plastic, metal wire or other material is pushed to form an object. The researchers observed the motion of the extruder using sensors and monitored sounds made by the printer via microphones. According to the researcher, just looking at the noise and the extruder's motion, we can figure out if the print process is following the design or a malicious defect is being introduced. A third method they developed is examining an object to see if it was printed correctly. Tiny gold nanoparticles acting as contrast agents are injected into the filament and sent with the 3D print design to the printing facility. Once the object is printed and shipped back, high-tech scanning reveals whether the nanoparticles, a few microns in diameter, have shifted in the object or have holes or other defects. This idea is kind of similar to the way contrast agents or dyes are used for more accurate imaging of tumors, as we see in MRIs or CT scans.